Good morning, students. Today we will discuss about this program Find S algorithm with the problem statement. Implement and demonstrate the Find S algorithm for finding the most specific hypothesis based on a given data set of training data samples. Read the training data from a CSV file. So here we need to implement the Find S algorithm. Okay, so using the CSV file, training data from that CSV file, we can implement the Find S algorithm. Okay, so here what is first we need to discuss about what is Find S algorithm. Find S algorithm starts from the most specific hypothesis and generalize it by considering only positive examples. So here we are finding the most specific hypothesis using this algorithm, and it will consider only positive examples. It won't consider negative examples. It will consider only positive examples. So Find S algorithm finds the most specific hypothesis that fit all positive examples. Okay, if you have a training data set, so this Find S algorithm, it finds the most specific hypothesis. It fits all positive examples. Hence, the Find S algorithm moves from the most specific hypothesis to most general hypothesis. Okay, so the Find S algorithm ignores the negative examples. So this is an example. Okay, we are taking. So this is the data set what we have. So here in that we have sky, air temperature, humidity, wind, water, forecast. Okay, so these are the 6 attributes we have, and this is the target attribute that will be the yes or no, that is positive or negative examples. So here for sky, here we have a sunny. Okay, so here we have 4 rows. So in that sunny, warm, normal, strong, warm, same. Okay, so based on this parameter, whether we will enjoy sports or not. So that is the data set here. So what we are doing in this Find S algorithm, first we will initialize H to most specific hypothesis. So here theta values are nothing but these are nothing but a most specific hypothesis. We will initialize H naught to all values theta based on how many attributes we have. Here we have 6 attributes. We will initialize 6 theta values. Okay, so here what we are doing, so here in this Find S algorithm, we are comparing the previous hypothesis and the current instance. When there is a difference, okay, so when there is a difference, we will go for the general hypothesis. If there is no difference, we'll keep the same value. So here in this first data set, okay, so here H naught is the initial hypothesis. Okay, so here when we have this initial hypothesis will be compared with the first instance x1. So here these are the first instance of x1. So here we are same thing. If when you compare with the specific hypothesis, this value, okay, so here same first step we will copy the all first instance values to the next hypothesis. Same values we are copying: sunny, warm, normal, strong, warm, same. Okay, so when you have a specific hypothesis and when you have a value, so we'll copy the same values to next hypothesis. Okay, so this is the first instance we are copying to H1. Okay, so next to take this in second iteration, we will take the x to second instance. Okay, we will take the second instance x2. Okay, here we have sunny, warm, high, strong, warm, same is there. So here we will compare with this values with the previous specific hypothesis. Okay, H1. Okay, so here sunny is there, sunny is there. Okay, sunny is there, sunny is there, same values. If there is the same values, keep the same values in the next hypothesis, H2. Okay, warm is there, warm is there. Both are same, keep the same values in the next hypothesis. So when you come to third one, okay, so here normal is there, here high is there. When there is a difference, normal and high, okay, the values are different. When there is a different values, so we will go for the general hypothesis. General hypothesis is nothing but a question mark. Okay, so next one here also strong is there, strong is both values are same. Then next values will be the strong. Here warm is there, warm is there. So both values are same. Here we will keep a warm. Same values we are keeping. When same is there, so we'll keep the same values. This is the next hypothesis H2. In iteration H2, we are getting the H2 hypothesis. These are the values of the H2. Okay, so come to next third instance. So in third instance, so this is negative example. Okay, the third instance is having negative example. So that's why we won't consider that one. We will ignore the third one. So this Same values should copy to H3. Sunny, warm, question mark, strong, warm, and same. Okay. So next, when you come to fourth instance, okay, this is the X4, this is the fourth instance, this is the previous hypothesis, H3, sunny, warm, question mark, strong, warm, same. Okay, so he compared with this previous hypothesis values with the current instance. So when there is a difference, go for the general hypothesis. If there is the same values, keep the same values. That's all. Okay, so here we have sun is there, keep the same value, and here warm is there, both are same values, keep the same values. So here question mark is there, here I is there. Okay, so when there is a question mark, when there is a high, we'll go for the general hypothesis. Okay, so then here strong is there, both are same, keep the same values. Next, this is very important. Here warm is there, cool is there. Okay, there is a difference, warm and cool, there is a difference. Then we will go for the general hypothesis. And same is there, change is there, we will go for the, okay, so same and change both are different. Okay, so we will go for general hypothesis. Okay, so when the values are different, then we will go for the general hypothesis. When we have a same values, we will go for the same value. Okay, so when there is a general hypothesis and when there is a values, we will go for the general hypothesis. So like that, this is the last instance, this is the final hypothesis we are getting for using this Find S algorithm. Okay, so this is an example of how to solving a Find S algorithm. Okay, now we will go for the program. Okay, I will explain the program now. So this is the program. Okay, so here implement and demonstrate the Find S algorithm for finding the most specific hypothesis based on the given data set of training data samples. Read the training data from CSV file. So this is the data set, whatever I have discussed, the same data set we are using. Okay, so enjoy sports. Okay, so here we have a 4 attributes. Okay, 4 rows are there and 6 attributes, and one is the final attributes. Okay, so here when you want to implement we are implementing this Find S algorithm using Python program. Okay, so here we are using the we are importing the 2 packages, NumPy and Pandas. Okay, NumPy is nothing but a numerical Python. Okay, so here we will have a, when you are using an array in Python, so here we will use this NumPy numerical Python, and Pandas we have one more. When you have a statistical analysis, so we will go for the Pandas package. Okay, so we are importing NumPy as a NP and import Pandas as a PD. Okay, so we are giving alias name for NumPy and we are giving alias name for Pandas. Okay, so here this data set is stored in one CSV file. Okay, so this data set without the just the training examples are there in the data set. That is, it start from Sunny to till X. Okay, so here we are storing that one in Find S. Okay, so this is the one CSV file. We are storing this data set. Then that one we will be reading. Okay, so here we will represent, whenever we want to do some calculation, we will represent the data in the form of 2-dimensional tabular form. Okay, that one will be done using this data frame. Okay, so when you want to represent the data in the form of tabular form, okay, in a 2-dimensional matrix, at that time we will use for data frame. So here we are reading the read CSV. This function is used to read a CSV file from the CSV file. Okay, so read underscore CSV. This is the file name. We are reading using this read CSV file, read CSV function in Pandas. Okay, that one will be stored in data. Okay, now data is contains the actual training data in this data, and that one will be converted into a data frame, that is representing a data in the form of 2-dimensional array. Okay, so that one we will call it as a data frame. That is one type of data type in the Pandas, in Python. Okay, so that one will be copied to data variable. Okay, now the data, it contains actual data. Okay, it is represented in the form of 2-dimensional array. Okay, we have loaded the data from the CSV file. Okay, after that we need to separate this target function and actual data. Okay, so here to go separate the data from the target variable, so here we will have a one function integer location. Okay, so ilog, that one we will call it as ilog. So using that ilog we are separating the columns. Okay, so here, okay, so separating the concept features from the target. Okay, so here we are, okay, we are removing that last column. Okay, so here this integer location, it contains starting row and ending row, and after that starting row and starting column and ending column. Okay, so here we are using, we are taking all the rows. Okay, and here this column start from 0 and it will be -1. So -1 means, suppose if it is start from 0 and 1 means, so 0th row and first row. So when you put a 0th column and first column, so when I put -1, it will be, when I put -1, it will be leave the last row except last row, last column, all columns should be copied. Okay, so it means all rows and except last column, everything will be copied to, we are converting that one as an array and that one will be copied to concept. Okay, so here using integer location, we are leaving the last column and all the, we are considering all the rows, and except last column we are considering all the columns, and we are converting that one into array and it will be stored in concept. Okay, so like that we are separating the, just so we have taken except last column, we are taking all the values. Now we are taking the last column using the same function, that is integer location. Okay, so here what we are doing, we are accepting all the rows, but here starting row we are not mentioning, just -1. So it means that is, it is extracting only last column. If it is 1, is means first column, but here we are putting -1. -1 is nothing but it is with the last column will be extracted and it will be converted into array and it will be stored in target. Okay, the target contains yes or no, positive, whether it will be positive or negative, that one will be stored in target. Okay, the concept contains the actual data. Okay, now we will define the function. Okay, define learn. Okay, we are passing the parameters concept, data, and target is target variable yes or no. So those two arrays we are passing. Okay, so here now actual function find S algorithm, we are implementing this learn function. Okay, so here what we are doing, so we are copying the concept contains the actual data, so we are copying the, okay, so we are copying the concepts of 0. Okay, that is, we are copying the first, what we are doing in this find S algorithm, we are copying the first instance to one specific edge. Okay, that one we are copying the first instance to specific edge. Okay, so now specific edge contains the first instance. Okay, so initial specific edge contains the first instance, that one we are copied. Now we need to do iterations. Okay, so we will compare that first specific edge with the next instance x2. X1 is copied to specific edge, x2 is comparing with that specific edge, that one we are doing in this iteration. Okay, so here we will use one enumerate function. So in that for loop we are using enumerate function. This enumerate function, it will use to count the number of iterations. Okay, it will be stored in that edge. Okay, so for i comma h in enumerate concepts. Okay, so here what we are doing, so we first what we are doing, we will check whether the target variable is yes or no. If it is yes, then we will go for, otherwise we will skip that one. Okay, so here if the target of I is yes, if the target target variable is yes, okay, so then what we are doing, so we need to compare the that suppose if we have a 6 attributes, we need to compare 6 times. Okay, so here that first attribute with the specific edge with the first attributes of the first instance. Okay, so like that we need to compare. So here for x in range length of specific edge. Okay, so suppose if the specific edge length, it will be 6. Okay, 6 times we need to compare. Okay, if h of x, okay, so if h of x is nothing but a current instance value is not equal to specific h of x, is not equal to specific h of x. Okay, so here that suppose if h of 0 is not equal to specific h of 0. Okay, if both are different, what we are doing, we are changing the we are going the general hypothesis for the specific h. Okay, so that is question mark. When there is a values are different, we'll go for the question mark for specific h. Okay, if there is no different, we are keeping the same value. When there is a values are different, we will go for the specific h, value will be the question mark. Okay, so like that we need to 6 times we need to compare the values of specific h and the h of x. Okay, so after that, once it lengths over, next we will go for the next instance. Okay, so this is the inner for loop. Okay, this is the inner for loop and this is the outer for loop. Okay, so then after that we need to return a specific, returning the final specific h value. Okay, so now once again we will call the iteration will be processed in based on that training example. Specific h is equal to here we are calling the learn of concept comma target by passing the, here we are calling the function, and finally we will print the specific h. Final hypothesis value will be the printing using this one. Okay, so this is an example and this is the output. We'll go for here this program will be executed in Spider programming. Okay, in Spider IDE. Okay, I will show that one. In Anaconda framework Spider IDE environment. So here same program I have typed here. Okay, whatever I have explained the program, same program I have typed, and I have stored the CSV file weather.csv in this file. I will show that file also. Okay. Okay, so this is the CSV file I have created here. Okay, so then I have created that one. So now I will execute that program using this run command. Okay, you can press F5 or you can use run command. Okay, when I execute this program, so in this console, output console, I will get an output. So here this is the data set what I have. Okay, same data sets I have used. So same data set I have here we are displaying, and this is the output. This is the final hypothesis whatever we are getting, that is sun, warm, question mark, question mark, question mark. This is the output. Okay.